Yeah. So do you remember this fish example? Classification of the fish. Do you remember? On the conveyor belt, a fish is passing, and we have discussed it somewhere in the class. You remember?
Yes, ma'am.
Yeah. So the objective here is on the so the task is like this. On the conveyor belt, fishes are passing, and so there is a camera attached to that which can capture the fishes that are passing on the conveyor belt, and the camera is connected to a computer from which where the machine learning algorithm is already deployed, and that will give the decisions, and based on the decision given by your model, so there will be a mechanical arm, so which puts your fish on the conveyor belt either to the salmon bin or to the sea bass bin. So that's what the problem is. That's what we discussed, right? And using this example, we'll be discussing this Bayesian decision theory. So the entire unit mostly will be quoting this example itself. So if you remember this example, so we have, so the same thing. So the objective is identifying the fish, either it as a salmon or sea bass. We are assuming that only these two types of fishes are passing on the conveyor belt. And because there are only two types of fish, we call this as a two-class classification problem. Okay, so we need to identify whether the given fish is the sea bass or the salmon fish. So please try to observe the nature of the fish. So like if you observe, no, the sea bass fish is quite wider and shorter, whereas salmon fish is lean and longer. Okay, color also you can observe because these properties will be using in the later classes. So before proceeding further, we need to define certain terms, the state of the nature. So we call the state of the nature as the object is belonging to which state. So that's what we call it as a state of the nature. Here, the objects are considered as fish. So the state of the nature of this problem is the fish is either belonging to salmon or sea bass. Say for example, gender classification problem. So in that case, given the test sample, so the person could be a male or could be a female. So that we call it as a state of the nature, right? So in this case, we assume that the given objective is represented with the omega. So object means like the fish, the given, oh sorry. So the salmon or the sea bass are the class names. And we use the class omega for describing the class. How many classes we have? We have two classes, the salmon and sea bass. And we'll be using omega 1 for sea bass and omega 2 for salmon. Okay, state of the nature indicates to which class this given example or the test sample is belonging to. That's what the state of the nature is. So as per the book it is defined, it's not that important. Yeah, now let's see how to take the decision rule. So decision rule, what do you mean by the decision rule? So based on some observation, so we'll take the decision, right? And ideally how the decision should be, so whichever the decision that is giving you the less error or the minimum loss, so that kind of decision you should take, right? Say for example, my problem is the gender classification problem. In that case, when a new person comes, my machine learning algorithm should classify them properly as, if it is a male, it should exactly classify it as a male, right? Or if it is a female, then it should classify it as a female only. Otherwise, there is an error, right? If there is a misclassification, then it's called as the loss or the error. So whenever you take the decision, so your decision should be such that it should incur minimum loss or minimum error. Say for example, in the medical image analysis. So given the image, the MR image of a person, so you should be able to identify whether the person is really having tumor or not, right? Or if it is present, whether it is a malignant tumor or benign tumor. So that is kind of taking the decision. So what action to take based on the observed input. So here in the fish example, so on capturing the fish, so your decision is classifying whether the fish is a salmon or sea bass. In the case of the tumor, so given the MR sample of the person, so your decision is to decide whether the person is having tumor or not, cancerous or non-cancerous tumor, something like that, right? So that's what the decision is. And you are following some rules to take the decision, and always what kind of decisions you should choose for is whichever is giving the minimum loss or the minimum error. So how to do that? Let's see. So before proceeding further, let's review the prior probability. So I have discussed this, but again, so the prior probability, it reflects our knowledge of, so like how likely a certain state of the nature is, you know, maybe you can see the fish example. So if you consider this fish example, what is the probability that, what is the percentage of the fish are salmon, or what are the percentage of the fish are sea bass? So maybe kind of, so in the gender classification problem, if you consider the prior probability, what is the percentage of the girl students? So can you tell me what percent of the students are girls in our college? Roughly. We have an idea, right? Usually, maybe 50%, 60%.
60 to 70.
Right? Yeah, 60 to 70. Okay. So in CSC, there are many girls. Okay. So that is what the prior probability is. So that's kind of, you know, about the state of the nature. That is about the classes. So what is the probability that this portion of the examples are belonging to this class? So that kind of prior knowledge is indicated by what we call it as prior probability. Okay. So in the fish example, so how many portion of the fish are belonging to salmon, or what percentage of the fish are belonging to sea bass? So that's what is given by the prior probability. And the prior probability may be depending on the situation also. Say for example, based on the season, so the proportion may change, right? The fish example. So that's how prior may not be the constant value. So it may change depending on the situation also, or sometimes it may be equal also. So the probability of girl students and the probability of female students and the male students, they are equal. So that also could be the case, right? So when the prior probabilities are equal, in that case, we call the prior probabilities are equal. And when they are equal, we call that as the uniform priors. Okay. So do you understand what the prior indicates? So prior just gives you the prior knowledge of the state of the nature, that is about the classes. What is the percentage of the samples that are belonging to the class? That's all. So that's about the prior probability. Now, depending on the prior probability, can we take the decisions? So that's what the question is. So before proceeding further, so let's see how do we formulate or the notation used for the prior probability. So prior probability for the class 1. So what did we define? What is omega 1? Omega 1. What is omega 1? Yeah, omega 1 and omega 2, we defined it, right? Yeah, what is omega 1? So omega 1, we are assuming that the sea bass class, the fish is belonging to sea bass class. Like omega 1 and omega 2, they indicate the classes, and class 1 is for sea bass and class 2 is for salmon. So please remember this. And now let's define the prior probability. How do we have the notation for the prior probability? So we can write the prior probability as probability of omega equal to omega 1, or simply we can write it as probability of omega 1. For which class prior probability this is? The class 1 prior. That is, what is the portion of the examples that are belonging to the sea bass or salmon? Yeah, similar is the sea bass fish, right? So probability of omega 1 is the prior probability for the sea bass. And similarly, we define probability of omega 2 as a prior probability for the salmon fish. That's how we define the prior probability. And one more thing you should understand is the summation over the prior probabilities across all the classes should sum up to 1. That is, if I have C number of classes, then the sum of the prior probabilities across all the classes is equal to 1. If you observe how many classes we have in the fish case, we have 2 classes. That is omega 1, the sea bass fish, and omega 2, the salmon fish. So probability of omega 1 plus probability of omega 2 equal to what? The probability should sum up to 1 in this case. The sum of prior probability should sum up to 1. Even if you have C classes also, it should sum up to 1. Say for example, in the gender classification. So what is the probability? If you assume that 40% of the students are male students and 60% of the students are female students. So then the prior probability of male class is 0.4 and the prior probability of female class is 0.6. Then 0.4 plus 0.6, that is, it sums up to 1, right? Yeah, please be interactive, no? So this kind of class, it's really tough to explain if you sit idle. Yeah, now can we take the decision rule based on the priors alone? Of course, when you don't have any other information. Say for example, consider the gender classification example itself. I don't have any other idea about the person. I'm going to derive a machine learning model. So given the person, I need to recognize whether the person is the male person or the female person. The only information that is given is the prior probability of the male student is 0.4 and the prior probability of female student is 0.6. Are you getting it? Hello.
Yes, ma'am.
Yeah, then,
Ma'am.
so can we, yes, can we take the decision based on the prior alone? So when the new person comes, I need to, my machine learning model has to recognize the person is the male person or the female person. Okay, that's what we are going to do. So the information that is given is only the prior probability. So how we can take the decision rule? So let's see, how do we take the decision? We can take is if the prior probability is of omega 1 is greater than prior probability of omega 2, then take the decision as omega 1. What do I mean by this? So you assign the person to the new to the class. So to whichever class the prior probability is higher, right? Does it make sense or not? When I don't have any other information, that's only clue, right? So now here we have only two classes. The fish is a salmon, sea bass fish, and the fish is a salmon fish. So if your prior probability for the class 1 is higher, then assign the new fish to the first class itself, right? So when this decision is false, this condition is false, then you assign the fish to omega 2, that is second class. So that's the decision I'm going to take. So do you understand what is going on? Can you look at
Yes,
this
ma'am.
equation? Yeah, it's very simple only, but you need to involve and understand, that's all. Yeah, then can you see any problem with the decision rule, or is it fair to do that? Is it fair to do that? If you cannot understand this, maybe you can, yeah, you can relate this example to the male and female. What we are doing, our classification problem is identifying whether the person is a male or female, right? The prior probability of male class is what? 0.6. Or consider this fish example itself. Now I have an example. Let's see that. So we are given the information that 60% of the total fish are sea bass fish and 40% of the fish are small salmon fish. Then what about the prior probabilities? Depending on this information that is given to us, then the prior probability of class 1 is 0.6, that is sea bass fish is 0.6, and the prior probability of class 2 is 0.4. And what is the decision you are going to take? What is the decision?
First one.
First class, right? Why are you taking it as a first class? Because
Yes,
your
ma'am.
prior probability of class 1 is higher than the prior probability of class 2, right? So because of this, you are, whatever the fish that come to you, you are assigning that to sea bass fish alone. Ante kada?
Yes,
Without any thought, without any thought process, you are just assigning all the fishes to the sea bass fish. Is it fine to do that?
no, ma'am.
Then what
No,
is the
ma'am.
problem? It's kind of whoever joins to the, like whoever comes to me, if I am the machine learning model, I am assigning all the persons to the female class because the prior probability of female class is more. 0.6 is the prior probability of the girl students, right? So whatever the person that comes to me, I am classifying them as a female student only. Will it be fine? Is the decision is fair? It's not, right? So there is a problem with this kind of decision rule. So then let's see what is the problem that is with this. What is the problem with this kind of decision rule? The problem is always you are choosing or you are assigning the given object to the same class. So in this case, whatever the fish that comes on the conveyor belt, you are assigning that to the CBAS bin only, right?
Yes, ma'am.
So even, yeah. So what is the error that you are incurring? Maybe errors we'll see in the later class, but can you see what is the error? Based on this decision, what is the error? Generally, you can observe and tell.
If the fish is sea bass, also sometimes we will say that it is salmon.
Yeah, that's fine. No, here everything we are assigned to CBAS only, right? Because it's belonging to 60%.
If it is
Even if,
salmon, we will sometimes
we are
say
assigning to, it's not sometimes,
Every time we
always we
say
are
C
assigning.
bars, ma'am.
Yeah, CBAS only. Then what is the error we are incurring?
Cool.
How much error we are incurring? Can I say that 40% of the examples are going into the wrong bin based on this information?
Yeah, yes, ma'am. Yes, ma'am.
Right? Yeah, that's what the error we are incurring. We'll see that later. We'll come back to that later. So like while discussing the errors on the decisions, we'll see that. So let's see what is the problem with this. So without having any idea, of course, with the data that is available, that is the better we can do. But there is a problem with this because always we are assigning to the same fish. And if, say, for example, if your prior probabilities are equal, then 50% of the examples you are misclassifying, right? So that's a problem with this kind of decision rule. Then what is the better way to do? Can you see, is there any better way to do? Hello.
Any
based on the
attributes into the
attributes.
Okay, based on the attributes, very good. So based on the length, right? Based on the length, light,
color.
we have seen
Color,
already. Yeah,
width.
color. Yeah, width. Very good, very good. So we'll see that. So of course, before proceeding, so we can decide based on the posterior probabilities. So how do you get the posterior probabilities? So based on the Bayesian decision rule, we have already discussed, no, what is the Bayesian decision rule is. So it can be computed as the posterior probability equal to likelihood into prior by evidence. So this is how we call it as. So the denominator term, we can call it as a marginalizing probability or the evidence. So whatever you call it, it's all the same. And likelihood into prior by evidence. So you need to find the posterior for every class. Say for example, I have some C number of classes. So for every jth class, you need to find the posterior probability. And the posterior probability can be computed as the likelihood of the given example. So here X is the given example and X given omega j. The probability of X given omega j is the class conditional probability. So how do we compute that? This we'll see in the next class. So this is called as a class conditional probability density function. And we already have seen that probability of omega 1 is a prior. And once we have these two quantities, earlier we don't have this likelihood, if you remember. Only information that was given to us was prior only. That's how our decision was. Assign the example to the class, to whichever class the prior is maximum. But now we are given the likelihood also. So given the likelihood and the prior, how can we change the decision? So we can use the Bayesian decision theory for that. So you compute the posterior for every example with respect to every class. So for the class J, this is how you can compute the posterior probability. And now what is the decision we can take? Of course, this is how we can compute this evidence and all. We'll see that later. Maybe we'll stop here. I'll just tell you what is the decision. So our decision could be something like this. To whichever class the posterior is maximum, to that class you assign the example. Does it make sense? So will it be better than that or not? We'll see in the next class. So how to compute the likelihood of the example. So if you understand that, maybe it makes much sense. So how do you compute the likelihood? So based on the parameters, as you already said, no. So you can use the lighting condition. You can use the what you call the width of the fish, the color of the fish. So all those can be used. All that information can be used while computing the likelihood. Then the prior anyhow we have, and using the prior and the likelihood, you can compute the posterior probability, and to whichever class the posterior is higher, to that class you assign. So what is this probability of omega 1 given X? What does it indicate? This indicates what is the probability that the given example X is belonging to class omega 1. And this probability indicates what is the probability that the given example X is belonging to class omega 2. So if this is greater, then assign to the class 1. If this is greater, then assign to class omega 2. So that's how we can take the decision based on the posterior. And in the next class, we'll see how to compute this. What is the class conditional density function and all, and how to compute the errors. What is the error that we are incurring? We'll see that in the next class, okay? Yeah, why I have stopped it here is because you need a lot of basics on, the probability theory. That's the problem. That's how I could not proceed further. And I know people are feeling bored when I teach the probability and all. So please go through the slide. Even I have recorded a video on this. So you can check out this video and complete at least the last portion of this. I think I have covered till here, if I am correct. Okay. Because if you don't understand these things, I cannot proceed further and complete. At least you should understand. So what is the conditional probability density function is, how to compute, and what are the different distributions you can use, the Bernoulli distribution, so the binomial distribution and the Gaussian distribution. So at least from here on, so you just try to understand at least these 3-4 slides, whatever the information is available that is in the 3-4 slides. Okay, so then it will be kind of a cakewalk for us. So let's stop it here for today. So which class it is? Third or second?
Third, ma'am.
Third.
Third.
Okay, thank you. So what happened? Why only 84 students? Supply?
Yes.
Training unda. Malli class enduku pettaru sir appudu?
First 3 hours classes.
84 students join ayyaru.
తర్వాత